Good evening, everybody. Thanks for dropping in this evening. Tonight, with myself, Alan Mercurio, and myself, we're proud to welcome Brian Kiernan, the National Sales Manager of Energy Kinetics. Hi, Brian. How are you?
I'm good, guys. How are you doing tonight?
Very good. Great to have you with us.
Always a pleasure to see you.
Let me get the big question of the night. This is the question on everybody's mind. I see this one all the time. It's the biggest question out there.
Hit me.
Can the manager cause the burner to go into lockout? Can it cause the primary control to go into safety? I see this like weekly on Facebook, all over the place.
The percentage of it happening, to quote a famous movie quote, 0.0, Mr. Blutowski. There is no possible way that our manager can make the primary control go out on lockout because it's just run through a set of dry contacts on our manager. It's never happened, and it never will.
You should put that in big block letters, like behind the manager. Because, I mean, that's probably the most common misconception. And that one, you see that, you just see it all the time. And,
almost daily, Bob.
I mean, an outsider sees it, every couple of days, multiple times a week. So I just want to get that one out there so everybody we don't have to deal with that.
And then we have folks argue with us. Don't tell me it doesn't do it. I've been doing this forever. I've seen it before, but I challenge that person to show it to me in a video, and it's never happened.
No, I get it. It can't.
No, our manager's pretty foolproof.
That's true. I don't think I've ever changed one. I don't do as many calls as I used to, but quite a few back in the day, and I don't believe some sensors and other stuff, but never changed the manager. Not a one.
The manager's biggest issue is a spike. We have a lot of stuff built into it to help prevent it from getting to the manager. On our relay board, we have redundant MOVs that take hits. Basically, we can actually use that board as a whole house surge protection. That's how strong we've built it into that board. It'll take the hit before the rest of the house. But again, as you know, with surges, if it's too big for anything, it will happen. It'll blow right through it.
Anything can happen.
Yeah.
Great. Glad to get that out of the way.
Cool.
What's the theory of operation? How does the system work? What makes it more efficient?
Basically, we operate just like a warm air furnace. That's our technology. We have a control that allows us to work just like a warm air furnace. We have a cold start, cold finish boiler, and it operates just like a warm air furnace. You have a thermostat call, burner comes on, the vessel heats up, gets to a certain temperature, the circulator comes on just like a fan on a furnace. It'll continue to cycle until the thermostat's satisfied, and then this is where our special trick comes in. It's called thermal purge. Just like a furnace that'll keep the fan blowing and get the heat out into the house, our thermal purge takes the heat left in the boiler and makes it run out through the baseboard, radiators, radiant, until the temperature on the boiler gets down to about 100 degrees, and then it goes back into standby mode. Thermal purge is the claim to our biggest energy savings. No minimal standby loss. I'd love to say none, but we do have some, but it's the least standby loss in the industry.
Great. I think people really they underestimate the effect that idle loss has on efficiency.
It's if you look at a standard boiler, who's ever, it can run almost 5,000 times a year or more just to maintain temperature. That's not giving you anything through your baseboard, rads, or through your hot water. That's just to maintain a temperature in a boiler in case you need something. So thus we've gone into the cold start, warm finish technology in boilers. And then we've been this way for 46 years, cold start, cold finish.
It's a great, I mean, if you had told me that 5,000 number a few years ago, I would have taken it with a grain of salt. So NORA's done some field testing, cycling,
right.
Actually logging cycles, 10, 12, 15,000 cycles a year.
With an average.
Yeah. So, I mean, no, I'm talking about a total cycle. So to have 5,000 of those be idle replacement calls isn't unbelievable.
It's a decent amount of fuel, especially if you're in the 1 gallon or 125 an hour range. That's a lot
even
of,
if those calls are a couple, 2-3 minutes apiece, you add those up. It's a huge number. And I had no idea before I started working for NORA that number could be that high. And even, people throwing out 10,000 a year, I thought that number was crazy high until you actually put loggers on, a dozen systems in the field. And that number's probably on the low side. It's
and
probably
it's been that way for a long time. I
Yeah.
remember when I first came to EK 20 years ago, Roger explained it to us that Brookhaven did that prior to NORA's lab and stuff. And I was totally blown away by the amount of wasteful cycles that are run on a boiler that maintains temperature. You know, you have a 10 to 12 gallon boiler that takes 15 to 20 minutes to get from cold start to temperature. We have a 2.5 gallon boiler that takes 90 seconds. Just that in itself is the tremendous savings. That's how we add up to 40% savings on our Frontiers, anything with a manager. And then with our hydrostat boilers, we can go up to 20%. You know, a lot of it just has to do from going from a massive boiler to a smaller boiler. You get the same amount of heat in the house. It's just not running as long to heat it back up.
Yeah, years ago, 20 years or so ago, I'd read the same B&L report.
Right.
So I don't know if I believed it or not, kind of. But I'm like, I got to really do the math myself behind this. So I just took a 4-section pin boiler, the weight of it, the weight of the block itself, plus the water content, how much energy was actually in there. It's a huge number. And I thought a lot of energy would be in the cast iron itself, the mass, and it's not. It's all in the water. Yep. I believe it's like 9% of the energy is stored in the cast iron itself. It's all the water content is just so huge. And I never really realized that until I started digging into the math behind it and realized
it is pretty amazing how much energy it takes. You take a giant pot of water to boiler for lobsters, per se. It takes half an hour to heat it up. Take a quart boiler or quart pan and boil it. It takes 5-7 minutes. That's the easiest way to explain it to a customer, and then they get it. It clicks.
You're storing a lot of energy there, and it's just sitting there. It's going to be all idle loss.
It is very true.
Another question people have: why no draft regulator?
Well, basically, what's a draft regulator designed to do? Control excessive draft, not create draft. That's an inducer's job. So with our spiral design, that helps us minimize excessive draft. A, so we're not pulling the flame off the head, and B, a barometric's probably one of the best basement vacuum cleaners you could ever put on a unit, because natural draft just pulls all that heat that's in your basement, and it's just pulling it 24/7 right out the chimney, out to the outside, and heating the good old outside instead of your house. So when John Marin designed it, there was no need for it after doing testing, and we do not use it. Not needed.
One of the first ones I did here 20-something years ago, the inspector had a problem with that. And after I showed them the install manual, they went along with it begrudgingly. But yeah, they went along. Wasn't happy about it, but went along with it. And that's another one. I mean, I had no idea the amount of air that's being pulled up the chimney all the time,
right,
by a draft regulator. Not just when the unit's in operation. It's a huge energy loss, which obviously increasing the infiltration into the house.
True. Besides the envelope, you're correct. You know, depending on the size of that boiler you have in there or the barometric, some of the size boilers can pull almost a full tank of fuel oil out of your house yearly. That's on the bigger size boiler, not the smaller ones, but a full tank of fuel wasted just going up your chimney. When John designed the boiler out here on Long Island, and when his brother asked him to come down and help him with it, the first thing he realized was we don't need to be big. We can do the same amount of heat in a smaller boiler with less water content and be very efficient. Thus, he took the hot air technology and applied it to a lower mass piece of equipment, and that's where we began 46 years ago.
It's a great idea. Actually, I'm glad you brought it up. Could you give us a brief history of EK, how the boiler was developed, where it came from, what was the idea, the thought process?
Sure. Well, it was the original oil shortage embargo that happened back in the 70s, and I know some guys on here might not realize it, but at the time, I used to have to go to the gas stations with my dad. I think it was Mondays and Thursdays, depending on your license plate, to get 10 gallons of gas.
I switched the plates.
I don't blame you. That's the New Yorker in you. I got it. But John Marin's brother owned the oil company out here on Long Island Marin Oil, and he called John and said, hey, listen, I'm getting killed. The price of oil, I forget the exact numbers, but it was catastrophic. The home heating oil went from this to this, and people are like, I can't afford it. The world's coming to an end. So John's brother said, listen, I need you to come down here. So John came down here. He started working on some designs in our factory, and I wish I would have brought a picture, is the original sketch that John did on the Long Island Expressway while he was sitting in traffic.
Yep.
And he designed the spiral design. He came down here, worked with his brother and also with Brookhaven National Labs on how to convert the hot air technology and the hot water technology, and they put it together. And John had a working boiler within 24 hours of that design, rolling it on a hose reel at his brother's oil company, the welder, putting it ever together, basically just slapping it together to see if it worked. And it did. And then that's when he got other people involved to test it and so forth. And back then, Brookhaven says, this is phenomenal. We never knew this could happen. And again, we saved a ton of people, a ton of money back in the 70s.
Yep.
Just by redesigning a smaller boiler and making it work like a warm air furnace. That was the whole design behind EK.
It was an interesting story. Actually, I saw one of the original colored ones, the dark, like a grayish metallic.
Yeah, it was the Battleship Gray, and that's another funny story. We were, and then Roger's mom, Lorraine, and John were at trade shows, and everybody had gray boilers. And Lorraine Marin said to John, "No one's coming in our booth. We got the same color boiler, just walking by." And the rumor has it, he said to Lorraine, "You pick the color." And here we have yellow. When they appeared at the home shows or the trade shows with yellow, the booths were packed because it was something new, something different, and it's something simple like that can show off your product.
Yeah.
I was actually in the business. I started in October 78, and the oil prices was 79. And when I started, it was around 38, 40 cents a gallon, something like that. And it basically doubled. And then over a very short period of time, went up to so the number you're saying people were furious about was 80 cents to $1.
Right.
That dollar barrier was just mind blowing. That was huge money, just insane.
Well, you had decades of inexpensive oil. They didn't care how it was burnt.
I started in October 78. It was around 40 cents a gallon retail. And then by next June, it had doubled. And then over the course of the summer, went up to $1, if not a little bit more, a couple cents over. And people were absolutely furious. Just that was insanity. We actually do have a question from Jeremy Martin about the venting topic. What's the significance on the EK1 of increasing from 4-inch to 5-inch right out of the breech?
Well, basically, we want to keep the heat inside that boiler as long as possible to get the best extraction from the flue gases into the vessel. We used to have 5-inch discharge on the side of the boilers when they first come out. But as we kept testing it and we got a lot of field input from the field saying, first of all, we're not happy with the original boiler was called the standard. It cleaned out the back. And unfortunately, a lot of installers would put it too close to the wall for you to actually be able to take the back door off.
I can vouch for that.
Properly. It's amazing, right?
A couple of bad experiences with that myself in the 90s. Yeah.
Ditto.
That wasn't fun.
When we took some of the field recommendations and we went from the standard rear clean out, we originally had it coming out of the side, the right side bottom. We developed it to take it out of the top. When we took it out of the top during the testing and so forth, we were finding that we were getting a lot of heat flowing out of the boiler quicker than we wanted it to. So during engineering, they decided, let's try it with 4-inch. Didn't affect the draft, didn't cause any positive draft over the fire or anything, but it helped keep the heat in the boiler enough to extract it quicker and put it into the house instead of up the chimney. But we do that just for the efficiencies. Now, we always recommend you go from 4 to 5-inch just so we have a stable draft going into the chimney. That's basically why we want you to do that.
Thank you. It answered the question. Hope that answers your question, Jeremy.
Yes. Good question.
Absolutely. On the infiltration combustion air thing, the outside air intake, what's the reasoning behind that? Having the burner in a box.
You can't control your environment in your basement. Wet basements, high humidity. You have cats, dogs, dryers that aren't vented outside. Again, you've got a burner with a giant fan and squirrel cage on it. It's another vacuum. So if you have all that stuff, and usually the washing machine, dryer, and so forth is near the boiler, and it gets pulled right into it. So the design was two things. We wanted to bring a cleaner combustion air in and make sure that we didn't have that contamination on the squirrel cage and through the flame. And also the side effect was we quieted that boiler down tremendously. Our decibel rating is less than a microwave oven when we're running an oil burner and a standard chimney. So that was the side benefit of us just getting a cleaner combustion.
It definitely works. It's amazing the noise level when you go on a job that doesn't have the outside air hooked up versus the ones that do. It's a huge energy savings, efficiency. Is there any energy savings with that, using the outside combustion air?
Well, you're not pulling heated air out of the basement, and the outside air is a little bit colder, So you're not going to really lose anything. So it kind of balances out. You're not pulling heated air and use it to go up the chimney, but you're pulling cleaner, cooler air in from the outside. It just makes for stable, balanced combustion.
Yeah, I think people lose sight of the amount of combustion air that is actually needed.
Just go in your basement, close your basement door, and stand there for about 2 minutes and put your hand or a tissue at your basement door and watch it just get pulled into the basement. That's how much combustion air a unit needs.
Yeah, it's about 1,500 cubic feet a gallon.
It's amazing.
1,500 cubic feet's a lot of air.
Yeah, and then they ask us, why are you only using 2-inch PVC? Well, numbers don't lie. We can pull that amount of air through 2-inch PVC. Some other manufacturers want 4-inch galvanized pipe and so forth, or flex pipe. We're fine with 2-inch. It just perfect.
Never had a problem with it.
No.
Plenty of them out there.
Yep, it also keeps the boiler cleaner, as we said before. If you got a dirty basement, which, there's plenty of them out there, you don't want to be pulling that dirt and putting it across your heat exchanger.
I like the idea of bringing it into the box rather than into the chassis.
Yes.
Yeah.
I put many air boots on. They work fine.
Yeah,
but
they work fine too, yeah.
But you have to have a barometric tamper on them, if I remember correctly, just in case something happens.
If you don't have it through.
If you don't have a fan,
you need the vacuum breaker if you don't have a pressure switch.
Right,
You don't have a way to prove it.
But and we've had those forever. So that's why we're able to do it with PVC. Now, we don't glue it. We tell you just screw it together in case you ever have to take it apart.
Yeah.
Been there, done that. I've had people glue them. What a... with the hacksaw. And then I learned the lesson. I started carrying 2-inch unions.
Yeah, that's a smart thing. Then it's, but you really don't have to. There's not that much air infiltration. You dry fit it, you put a couple of slip screws in it, and you're good to go.
Yeah, people would glue them, and then you couldn't get the thing apart. And then run it straight down to the floor. I've seen them
duct tape together. They cut it, didn't have a firm core coupling. There's FSK tape or duct tape,
I used a couple of sheet metal screws.
Yeah, they work great.
Too. Yeah, but the ones that ones that glued were a pain in the neck. Joe Egenberger has a question, which Alan shared with us up on the screen. Can you see that, Brian?
Yes, I do. Should we be setting the CO2 higher and colder? No. We have a wide window that we operate in. Prior to this year, we always wanted you to set it up between 10.5 and 11 CO2. But since we did a lot of testing with the B100 certification, and I think the industry's been burning ultra low sulfur home heating fuel for 5 to 7 years now or longer.
13 in New York. 13.
During that testing, we found we can now up the CO2 to 11.5 to 12.5, which when I got into it, somebody would shoot you. You don't want to be anywhere near that. You're going to soot the boiler up. But this new fuel oil, prior to the biofuels and renewable diesel, has done wonders for the business. It's made our emissions as clean as natural gas and propane, if not cleaner. So we have adjusted our standings now. We want you to set them between 11.5 and 12.5. And that 1% is enough to cover the warm months and the cold months, Joe.
You get some tempering, too, with the box. You're not bringing air directly into the chassis. You bring it into the enclosure, and you get the boiler temp there.
Yep.
Well, and the distance through the house. Thanks. I'm just going to read Joe's question real quick for the people who aren't watching, just listening. And it's the topic of outside combustion air. In the summer, should we be setting the CO2 higher so that when the air is colder, CO2 drops? Very good question.
It's a great question.
Yeah. Thanks for that.
But if you're in our range, we're happy.
Yep. Okay. I wasn't aware that you ranged the range. I was still used to the old...
I got that memo a little late, too.
Okay. I just got it now.
Well, see, we're here for something, right?
Yep. Anyway, while we're on venting, the dilution venting.
Oh, greatest thing we ever invented. Or not invented, we implemented on our equipment. Yeah. Our dilution air venting system is great. We had a couple of hiccups with our first, I shouldn't say our first. We first came out with the 90 plus Resolute, which was just a standard inducer mounted on a Z-Vent T about 16 inches off top of the boiler. That allowed us to mix the outside air with the combustion air. And by doing that, we were able to put an extra wrap of flue box around our vessel. So instead of bringing 350 degree out to go into the chimney, now we're coming out with 250 degrees. Now you take your outside air and mix it with that at the inducer, with the combustion air going into the inducer and the fresh air coming in also to the inducer. Now we're dropping the temperature down to about 200, 180. So now we're able to get a boiler that's discharging 180 degrees temperature, but we haven't lowered the internal temperature to condensing point, which I believe is 180 or lower. So we're still coming out of the boiler about 250. In the dilution air venting, we're cooling it down a little more, and now we're venting out between 180 and 200 degrees, depending on the time of year. It has really allowed us to do a lot with our equipment. We took that, and now we've able to get an 87, 88 AFUE boiler up to 91 plus, venting it through plastic polypropylene oil. We've been doing that for about 10, 11 years now, and it's phenomenal. When we went to our second version of that, we started using a black plastic Fasco inducer that has had a couple of issues with installations. If you didn't install it properly, there were some issues. We realized that. We redesigned it now to a stainless steel box with our standard Fasco squirrel cage and motor on it. And that has taken care of a lot of the installation related problems, and we were having great success with that. And it is a 30-year proven inducer technology. The previous one that we used from Fasco had been used on water heaters for decades. So when we engineered it, we were told by them it'll be fine, but we couldn't control whether the exhaust pipe and fresh air was piped properly. We needed a restrictor here and not there, depending on the length of your exhaust pipe. So with this new one, we have it down pat. If it's 2 elbows and 10 feet of pipe, there is a restrictor possibly needed. Anything after that, you don't need it. But with the combustion air, we always tell you to verify your draft issues or draft readings over fire and actually at the inducer.
Yeah, I was going to ask that question. Is it adjustable? Like the dilution ratio, it's factory set, it's preset?
Factory set, no damper needed. We do still possibly need a little plastic restrictor if it's a real short length, because that inducer is very powerful. And we want to make sure that we're not pulling too much draft through the boiler, because we're still utilizing pressure switches on our puff switches on our boilers.
Yeah, obviously it's
power. Right, we have our standard one on the front of the boiler in case you have a blockage, and then we have a dual one on the inducer that senses the exhaust output and the air intake. So it's balanced. If anything gets out of whack, it'll shut it down, so there's no issues. And on this new inducer, we also, like our prior inducer, we have the thermal reset switch, just like Field does and stuff. It pops, it's a manual reset, clicks on switch, and it's required, and we have it on our units.
So between the boiler and the inducer, you're going with stainless steel and then poly after that on the out, on the diluted side.
Right, on the exhaust, we don't believe in PVC for exhaust for many reasons, and that's another story you can get into another time. But
3 days on that.
Yeah, but PVC for air intake is fine. But we sell both kits. If you want to do it coming out the wall the same color, we have a air intake kit in polypropylene. We have the exhaust in polypropylene.
Nice. I can see the dilution venting becoming more popular. I mean, it's kind of on hold right now with the DOE and
I know. That whole thing is up in the air, from what I understand. Of course, would know more.
Yeah, it's paused at the moment, so the DOE is not going to raise the minimum efficiency requirements for boiler and furnaces for the near future anyway. But I mean, a couple of years ago, it was looking like it was going to happen, and in the future, anything can happen. It probably will. And
very true, but think about it, Bob. With dilution air venting, your discharge temperatures now down around 200 degrees instead of 350, 400.
Yeah, you can take it. That
turns into savings.
Yeah, I could see dilution venting systems really taking off if that ever happened, versus the alternative of under firing boilers to pump up the.
I think you'll see us progressing with it. I think we love it, and we're going to.
I can see the industry taking over the dilution venting system.
Which is a good thing. We all have to be on the same page. There's enough business for all of us, and oil heat's never going to go away in our lifetime, and you and I know that.
So we may be burning a different fuel.
Let me repeat myself differently.
I knew what you meant.
Yeah, I am really excited to see where biofuel goes and renewable diesel. As you know, we've been part of the new study with you guys, the RD80 and the B20 in different states, and we're psyched to see how that goes.
Got a question from Alan Warner, which I'll read, because people who can't see it. With bio and no sulfur, will blue flame and dilution venting work?
That's a good question, Al, because with the blue flame, you have to have so much higher pump pressure, if I am correct. And I don't have that answer for you. That would be something for our engineers to work on, but I can tell you that we're not working on blue flame at the moment.
I think the early 80s blue flame technology was probably premature. The technology to implement the idea wasn't there yet.
Right.
But it's an idea that it's time may have come.
Great idea.
Yeah,
they've been doing it in Europe for how long?
We'll see what happens.
Yeah.
Actually in the UK it's basically standard. You need to get a variance if you have a non-condensing appliance.
Right.
And there's strict NOx limits, so they're all basically blue flame in Europe, 90%.
And on that,
got another question from Jeremy Martin about direct vent, which is really power vented, right?
Well, there's still, the New Yorker had that direct vent to Microtech, or you'll never see us do it because we have a gasketed boiler, and you would have to run underneath a positive pressure from the time it exits the flame or the burner until it exits the house. And you can't control who opens and closes the unit if you don't seal it right. I've got it right from the horse's mouth that we're not interested in going to a direct vent without a mechanical assist.
I think having the boiler under negative pressure makes a lot of sense.
Yeah, because you can't control the environment it's in or who touches it. And that's not a negative, but it happens.
No pun intended, right? That's not a negative?
No pun intended, yeah. I mean, just look at how many times you've gone into a basement and there's 10 pounds of furnace cement where there should be a nice gasket. Imagine if we pressurize that.
It's another one where the idea, I think, is great. It seems so simple, right? I mean, there's no, one fan. Let the burner fan do all the work and pressurize it. But it's another one of those where the idea is great, but then the execution sometimes is tough. And not from the manufacturer's point. What happens in the field afterwards? Yeah. It's a crapshoot. Yes,
I mean, on that point for years now, and I know it's just specific to EK, we've been teaching technicians in our factory that before you clean a boiler, we give you 2 test ports, over fire and breach. We really want you to check the draft, over fire and over breach. If there's no more than 0.4 of an inch water column difference, the boiler's clean, don't open it. That's coming from an OEM. But companies have contracts. If the customer doesn't hear a vacuum, they're going to call the office and say, your guy didn't vacuum my boiler. When technically, every time you open and close our equipment, there's a gasket. There's a 2-inch board, and it will wear out. If you don't have to open it, why? I just had a call today. A boiler, it's only 15 years old, steamed because nobody checked the safeties. Nobody checked the low water cutoff. You should be checking your high limits and your low water cutoffs during every PM. And guys do, but guys don't. And they do fail. That's why you check them. So if you take the time that it takes to opening that boiler and look at it and see there's nothing in it because of the fuels today and it's properly set up, and you just check the safeties more in depth, we'd have a lot less issues in the field. And that's my personal opinion.
Yeah. So thinking of your response to that, and it made sense because he's talking direct vent, but I'm just going to put up on the screen here.
Sure.
He said he's sorry. He really meant that he was referring to the power vented model, not the direct vent. Does that change, or do you still feel the same?
Oh, it changes because, again, what was the biggest problem with power venters? They were running at 400, 500, 550 degrees.
Yeah. Yep.
And if I remember correctly, the bearings on most power venters are 500 to 500 degree maximum. And many older boilers were, and then 6 months in, you get the bearing rumbling, soot in the joist bays, the side of the house gets sooted up, not because of the fuel, because you're not getting the proper draft getting pumped out. I think that the dilution air venting is the way of the future because that takes that right off the board. You don't have the high temperature. You don't have the squirrel cages and motors wearing out. And you have that customer saying, I can hear my boiler running under the living room or in bedroom. It's necessary at the point right now to continue doing that. But I really hope that they go away and we start getting into more manufacturers using dilution air venting. Just so much easier.
Is there any concern with condensation in the poly pipe after the dilution?
No, because it's dried out by the outside air. So 250 degrees, say 50 degree air outside, as it comes and mixes it before it goes out the inducer, it dries it out. We very seldomly have any moisture coming into our poly. Now, we do have chimney kits. They can go as tall as 50 feet up. We insist that you put a condensate trap where it comes out of the chimney just in case, because that's an environment we can't control, that long, cold chimney.
Yeah.
going out the wall is never that I've seen any major condensation. But a chimney vent, we definitely want you to put a condensate trap on it and take it to the nearest drain or pump.
Sounds good.
Or we're beating it, right?
Yeah, yes. Switching gears real quick.
These are good questions.
Domestic hot water.
Oh.
How do you guys make domestic hot? I mean, you hear a lot of things about the pump and the flat plate, and why?
A domestic plate heat exchanger is probably the most efficient way and the quickest way to heat hot water that's ever been made. Everybody's using them. The wall-hung boilers, we started using back in the late 70s. John Marin actually worked for the company that manufactured them before he became Energy Kinetics, and he utilized the efficiency of it. For something that looks like a brick, to take 200 degrees and circulate 50-degree waters across it and have a 70-degree temperature rise and heat a 40-gallon storage tank in 15 minutes or less, it beats the pants off of every other coil out there. So John tested it. He said, this is the way to go, and we have never changed course, except that the downside of the original plate exchangers were very sensitive to water quality. If you had hardness or calcium or iron, again, going back to the boiling water in a pot, if you boil that water and you turn it off, and if you got some water in it, you're going to get that ring around that pot on the stove. The plate exchanger on our boilers run on bypass. And when you ran in the heating mode, you kind of cooked the water on the domestic side because you're getting it up to about 200 degrees. And then it would start blocking the micropasses in the plate exchanger. About 4 years ago, Schwepp came to us and said, we have a new coating called Celix. It's being used in Europe, and it actually coats the inside of the plate exchanger on both the boiler side and the domestic side, and it prevents that from sticking into it, any of the hardness, iron, or calcium. The other thing we've done, and I'll get back to the efficiency in a second, the biggest issue we have in those things is water quality. Nobody addresses the water quality when they go in the house. They just want to know what needs to heat the house, how much hot water you need. They want to make sure that's covered. But one of the biggest disservices that we find is the water quality is never addressed because water isn't what it used to be. I'm from Pennsylvania. Our water is very hard. I hear there's a lot of hard water in many states. And hard water is just one of our biggest Achilles heels. So we've adapted. We have what's called a scale stopper. It's made by AquaPure. It's a spin-on filter. It'll treat the hard water up to 25 grains of hardness. So you don't need a big salt tank and a $4,000 or $5,000 water conditioner. And you change that cartridge once a year during the cleaning, and the cartridge is like $30. That and the Celix plate exchanger extends the lifespan of that plate exchanger, so you can continue to get endless hot water with our equipment as long as the passages are open.
Got a question from Joe Egenberger.
We do mount them flat. We used to mount them vertically. Basically, Joe, what we're trying to do is get so it doesn't lay on the bottom of the plate vertically. If you lay it flat, all 4 exits and entrances go out the bottom, and any tendency, the stuff will float to the bottom and get pushed down back into the boiler or back into your tank or out through the faucet. The other big thing we're pushing is we are trying to sell our equipment with the plate exchanger pre-mounted to the tank. So now every time water runs through that plate exchanger on the heating side, it's running on the domestic side, so you don't have the chance to cook that water while it's in the heating mode. So we're taking it out of the plate exchanger out of our bypass. We're mounting it to the tank with the 006 bronze circulator and the piping, and you hook it up as a zone. Now we've taken hard water situations and done the best we can without treating the whole house, and we're able to now save that plate exchanger for years instead of it might go in a year with some bad hard water.
Nice.
Yeah, I didn't even give that some thought. I remember the old vertical ones.
Yeah. On the original Frontiers, they're mounted vertical, and everything flew out the bottom. Basically, when we went to the Frontier design, we laid it flat, just for the simple reason that what goes in will come back out both sides, and it won't stack up on the bottom. And I'm not sure if that's the engineering idea to it, but it seems to work because everything will then flow back down to where it came from.
Makes sense.
Yeah.
Thank you. We got another question from David McDonough. Is there any additional maintenance needed on the heat exchanger?
You should always backflush it once a year. We send our boilers that has, you'll have your plate exchanger mounted wherever it is. It'll come out of it. You'll have your 006 brass circulator, bronze circulator, and then you'll have a ball valve below it. On the top of the circulator, we have a boiler drain. So we give you a backflush opportunity. So every year during your servicing, I usually tell guys, go in there with a Gatorade bottle, make sure it's clean, run a quarter water in it and set it down there and let it sit for about a minute. If you see any sediment building up in the bottom of that bottle or a bucket, a clean bucket, it might be a good idea to go out and get a longer hose and flush that plate for a couple of minutes to get any sediment that might be laying in that plate out. Good point. Very good question, David.
Jeremy has another question. This is from Jerry Martin. Just making sure I heard correct. Plate exchanger is a zone and not a bypass is preferred?
Yes. We are trying to push our customers to go that way to extend the lifespan because the customer doesn't seem to care unless they're informed about the water quality in the house. So we want to make sure the equipment that just paid thousands for lasts for a while. So we're taking the initiative to make it so it's not foolproof, but we're giving that plate exchanger as long a life expectancy as we can without anybody else being involved in the situation, if that makes any sense.
It does. Good answer. Thank you. Got another question from David McDonough. Oh, I skipped him. I'll get back to him. From Joe Eatonberger. Can the scale stopper be mounted in any position? I
see them every position possible, Joe. We recommend them in horizontal position because the actual head is a Venturi type head. So as the water runs across the scale stopper, it pulls the treated water out and flows through. I've seen them mounted horizontally like this, and I can only imagine that you're getting a lot more of the media out of it than it's necessary.
Thank you. Lots of good questions tonight. Getting back to David. Sorry about that. Do you require any bypass popping on larger pipes on older home using cast iron radiators?
Mandatory.
Not a W question, but a good question.
Very good question. We have two options for that. We have what's called our high mass, low mass injection kit. We sell you, it's a set of injection tees, two isolation valves, and a primary secondary pump. That will take the 80% of the mass of the house and keep it circulating, while the other 20 to 30% just injects into it. And it lets that boiler run in a nice long cycle instead of short cycles, on and off, and preventing early premature death of zone valves and circulators. And the other thing that's mandatory, and it's I'm saying it's mandatory because I deal with the calls all the time, you should be utilizing at least the dirt mag separator on any steel mains with radiators or old steel pipes. There's so much stuff in there. You put a low mass boiler, whether it's a wall hung or our boiler, it's going to end up in the tightest spot of that boiler, and you're going to get a service call for an overheating. We have just started utilizing hydraulic separators more. When we get into the bigger systems, they're a wonderful tool to use to keep the boiler healthy and also make sure that it's not affecting that boiler's operation. Good question.
Yeah, lots of good questions this evening. Thank you. Okay. Actually, I was going to ask that question, but now that it's gone with the large mass systems, there we go.
I'm becoming more of a fan of the hydraulic separators because it comes a mixing chamber. Our high mass is just an injection loop, but some of the mains we get into, like Philadelphia, New York, 4-inch mains, and you're putting a 2.5 gallon boiler in there. And I just believe it's probably a more evenly mixed water flow when you use a hydraulic separator. Price-wise, they're probably not that far different. I can tell you, I know from my own pricing that they're plus or minus $100 depending on whose model you use, and it's worth it. One service call is going to ruin profit on your install. So if you put the right equipment in, you're saving yourself money.
Yeah, I think there's less to go wrong with the hydraulic separation too. It's easier for people to understand in the field service-wise, and you're getting complete decoupling, right?
Yeah, and you got air. You got air coming out of the air scoop. You got a magnet in it. Depending on which one you're using, you can take them apart, check it, or you can pull a magnet, drain off the bottom. It's the lifesaver for any boiler.
Yeah, it solves a lot of issues.
It does.
Thank you. Manager, how does it work? What does it do? And then we can get back to whose question it was earlier.
Yeah, that's Alan. While he's talking, I'll just put that question up if you want, Bob.
Sure. Question.
My buddy Alan Jackson.
Please explain the low voltage wiring for Wi-Fi stats off the manager.
All right, great question, Alan. So depending on which Wi-Fi's you use, I'm not going to go down the Nest path because they're just a whole nother story in itself. You know, all the different versions, 1 and 2 are no longer being supported, but a Wi-Fi stat generally needs a common wire because there's a battery in the stat that has to be charged in the off cycle, trickle cycle. On our managers, we have A1, which is 24 volts. We have A2, which is your common, and then your thermostat call would be your actual W. So you can have R, C, and W supplied to you from our manager. You just have to get it up to the thermostat. Now, on a lot of the older systems, there's only 2 wires that comes from the thermostat down to the boiler. There's 2 ways that can do it. We use a resistor that goes between our common A2 and the thermostat that this Wi-Fi stat's on. That allows it to trickle charge in the off cycle without using anything else. That's the simplest way. You're looking at $1 for the resistor, or the thermistor, I'm sorry, and it just works great. There's called a wire maker that you can get online. You have to have a unit up at the thermostat, one down at the unit. It does the same thing effectively. And then you can also use a rib relay if you get into a more difficult situation. But our managers can handle the Wi-Fi stats, no problem. The only one that couldn't was our classic manager. For some odd reason, even though we had A1 and A2, you could put the resistor on it, but I wouldn't recommend doing that. I would either upgrade to our new display manager, which when we designed it has this built into it, so you really don't need the resistor. You can just run the wires and you won't get any phantom lights from a battery seeking charging out of our manager.
How many thermostats can you run off the transformer in the system?
All right, so on our 5-zone manager, we have a 50 VA transformer. We're figuring 10 VA per zone. 15-zone manager, you need 150 VA, so we send you 350 VA transformers if you were to do a bigger manager. Now, the one thing that we've run into is if you put more than 5 Wi-Fi stats on it, on a 5-zone, you might want to go to a 75 VA because there's a lot of power being taken off of that manager. And let's say they're all charging at one moment. That's a lot of power. So we recommend you go to a 75 VA on a 5-zone. But normally on a 15-zone, you're not going to have 15 Wi-Fis, and the 150 VA transformer should be able to take care of it. Should work fine.
Thank you. Great question. I mean, the Wi-Fi thing is a constant nightmare.
It's a nightmare because of Lowe's, Home Depot, selling to homeowners. They go home and I can do this, and the next thing you know, the tech's getting a call, and I get it.
It's just a nightmare on everything, not just energy. It's everywhere.
It is.
It's just a big pain. Troubleshooting the manager.
Actually, our manager has a built-in 2-minute self-check. So it's real simple. If you have no calls for heat coming from the thermostats or from the hot water tank, we want you to turn the system switch off on the left-hand side of the manager. Wait a couple seconds, turn it back on, and look at the lights. On our digital manager, you're going to have a temperature readout in the middle of the manager. When you flick it back on, the lights are going to light up on the input side from the thermostats. They're going to light up for a second and go off. And the temperature bar is going to go up and go down. That's a pre-check, a self-check that's letting you know that something's good, the manager's okay. If you walk onto a manager and the only thing you see on it is the power light, that automatically tells you that the manager's just sitting there waiting for a call. I'm here, tell me what to do and let me do it. That's the basic operation of it. I'll get into troubleshooting in a second, but basically once you get a call for heat, your thermostat lights up, the zone valve and the circulator and the burner come on right away. They run for about 90 seconds. For oil, we want it to get up to 140 before the zone valves open. For gas, we want it to get up to 150 before it gets open, and at that point, it'll start falling out to the house. Thermostat satisfies, thermostat light goes out, zone valve that's been running stays on, circulator stays on, burner drops out. That's our thermal purge. That's the basic operation. Now, troubleshooting. Our managers, and a lot of guys tell me I'm crazy for this, but we have a built-in meter on our manager. I call it that. So if you turn on a zone on the first floor and that thermostat lights up. You've basically just ohmed out from the manager connections, thermostat or T1 and A1, all the way out through the wire, through the thermostat and back, as if you put an ohm meter on it. You get a light on the manager, you've got a clean, unbroken or uncompromised circuit, and you're good to go. So you didn't even have to take a meter out. If you watch the temperature bars rise, once you get to 140, you see the output light opposite from the thermostat's calling. That just told you that the circuitry through the manager to that zone valve is fine. As long as your circulator light is on and your burner light is on when it's supposed to be, or if you're using an inducer, that's basically, it's telling you what's going on. And if it's not going on, we have built-in codes. The most popular one is the 100-degree code. It tells you that our digital temperature sensor, which is the operating aquastat on our boiler, is failed. So you're going to need to replace it. That's our digital temperature sensor. We have now gone to our thermistor digital temperature sensor, or display temperature sensor. It has two thermistors in it that sense temperature. You're still going to get a code on the manager that says E100, check sensor. On a digital manager, the light's going to blink 100 degrees. That tells you something's up with the sensor. Now, if the sensor fails, you're not going to be left without any heat. That's our operating control. It's going to now run off your high limit. So instead of running about 180 degrees, the boiler's going to go up to the high limit of 215 and stay hot. That's usually why you get a call. The customer will say the boiler's hot all the time, but I'm not calling for heat. On the other side, you have code 140. Code 140 is telling you that you have tried to achieve a temperature in a certain period of time, and it hasn't achieved it. So it's going to blink 140. So it's one of two options. Either the burner's off on safety, out of fuel, bad motor, whatever's wrong with the burner, or you have no circulation. So you're unable to get the boiler circulating past either the digital temperature sensor or the thermistor, and it's going to give you that code and tell you, hey, I got a problem. Come fix me. And then you go out there and you do your ABCs on the burner. If the burner's not off on safety, you do your ABCs on the hydronics, from the output to the zone valves to the circulators. Check your circulator, check your zone valves, fix whatever's going on, and you set the manager back up, turn it off, turn it back on. You'll clear the code, and you'll know right away if you fix the digital temperature sensor, because if you didn't, it will blink 100 degrees right away. But it's going to take up to 20 minutes for it to try the 140 code and see if it'll heat the boiler up enough to keep it from giving you that code. So it's going to take you about 20 minutes, really about 10 minutes. If it's not up to 10 minutes, you're going to get a code on a new display manager. So before you even get your tools away, you're going to know that you've resolved the problem either way. Hopefully that helps with the diagnosis.
I think the 140 code is the one I've seen the most often, and it's
the most popular.
Yeah, and 9 times out of 10, it's a burner issue.
Most common.
Yeah, it's obviously it's a burner issue, which obviously in this business, burner issues are what we do, right? It's what you see every day.
And the best thing that I've seen happen in this industry is Carlin and Beckett have both come out with those controls that log your faults and your details.
Yep.
It's no more guessing. The block vent switches have saved us tremendously because we use a block vent switch on all our boilers.
Yeah.
You push a button, it says BV, you know right where to check.
Yep.
You go into your lockouts. I was watching John talk about it. And Beckett, low amps, high amps, it's telling you what to look for. I wish we had this 40 years ago. You're scratching your head, pulling your hair out. That's why most of us are half bald.
Half.
Well,
I'd be happy.
I'm trying to be generous, Bob. I'm just kidding.
I mean, I agree. That was the only, prior to those type of controls, the block vent situation could be a nuisance because you guys were breaking the CAD cell circuit.
Yeah, we did.
You get random lockouts, and when you get a burner in safety, you automatically start with the filter, the line, fuel, supply situation, and then it would turn out later on that you had it was really a draft situation.
Yeah, but they jump. That was the sad part. Without that block vent code to tell you what to look, most guys that didn't know how to work on us would just jump the pressure switch and let it run and leave.
No, I went back and continued to do it, but I know
you did. But
callbacks involved. Yeah, never jumped it. Not a good idea, obviously.
It's not recommended by us at all.
Yeah, being able to show the code and have the block vent switch is
Yeah,
Huge.
those companies have done a tremendous amount of help for the industry.
Both those control. I mean, honestly, I can't say enough. I had an on watch, which
I
cost a
remember that.
fortune.
Yeah.
The old on watch came in a suitcase. I still have it.
And the
over
big suitcase. Yeah, we had them
Yeah.
too. We used to take out. Yeah.
here. Yeah, and I mean, you know, the first call, and you know, something should have it with you. You had to go back, put it on, and you had to go back and read the data and figure it out. So you're good for 3 or 4 calls.
Yeah.
And I mean, now every job that has one of those controls has a permanent on watch built in, basically.
Yeah.
It's there when you get there. You know, it's been a huge. I think it's been huge for the industry. It's going to be better going forward as they improve it. You know,
Yeah. I was hearing, John, what they're doing with the white. I know I'm getting off topic, but
yeah.
I salute those guys.
It's definitely a better world for oil burner technicians, that's for sure.
Yeah.
The Ascent.
Oh,
what's the deal with the Ascent?
So basically, we partner up with NORA to make a more efficient tankless coil boiler. And we are the first manufacturer to actually make a more advanced tankless coil boiler in 50 years. We took a giant 12, 15-gallon boiler with an immersed coil that promised you 5 gallons a minute, which it never gave you because you had such a big swing in the temperature in the boiler. And we tried doing it with our Frontier, but unfortunately, we didn't have enough water content in the boiler to produce that 5 gallons a minute. So we tried it with our EK2. We had plenty of water in the boiler, but it got too hot. It was not efficient. So Roger and the engineers went into the lab and they created our new vessel that the Ascent is built on. It holds 3 gallons of water. Now that was the perfect amount of water to give us the perfect amount of flow and the perfect amount of hot water per minute. That's made us, it's probably our biggest selling boiler we've ever come out with. Our Frontier's our number 1 seller still, but the Ascent is number 2. People love it. It's designed to be service friendly. You have 4 3/4-inch union nuts to change the coil. You don't have to worry about gaskets, snapping nuts and bolts.
Flat plate, you said coil.
I'm sorry?
Flat plate, you said coil.
Flat plate, sorry. Our flat plate exchanger. Instead of a submerged coil, you don't have to drain boilers. You don't have to spend a day tapping. So that's what we did it. We teamed it up with a heavy-duty Caleffi mixing valve, which those things can take a lot of abuse. And it gives you about a 1/2 degree temperature swing maximum. So you're not getting those ice cold waves coming out of your hot water faucet with our flat plate heat exchanger. We also use a 007 on our bypass to flow through the hot water, or the boiler side, to keep the temperature in the plate elevated enough that we can strip every ounce of hot water out of that boiler possible, run it through the mixing valve, and give you anywhere between 120 and 130 degrees, nonstop, 24/7, with a priority flow switch. So that's our claim to fame with the Ascent.
Can you go over really quickly the operating modes?
Sure, that's the best part about it.
That's why
Again, Hydro Level came to us. We went to them and said, listen, we're making this new flat plate exchanger boiler, low mass, just getting the tankless coil boilers up to speed. And we want to put some efficiency in it. But at the time, the hydrostat, I think the 3250, only had maintained temperature and cold start, warm finish. And we went to them and they grabbed it. They said, what do you want? Our engineers told them, we want to be able to remember your hot water usage. We want to know that if you get up at 5 o'clock in the morning and you do that day after day, we want that hydrostat to remember that. So after about 3-4 days, it's going to save that time and come on half an hour before that 5 o'clock time frame. So the boiler comes on at 4:30 and is now hot and ready for you when you get up to go in and shower, shave, and get ready for work. Once the water stops calling, it'll go back into sleep mode, but it's called it option 3 and option 4 instead of just your basic 2 options. 3 and 4 are learning modes. They just have different time constraints on them and how long they learn and how long before they go into vacation mode. So they're basically like OP1 or option 1 to maintain temperature, but they learn your usage, and the best time to use them is in the spring, summer, and fall. So there's no need to maintain temperature for the boiler in that time. That's where we get into our savings.
Yes.
Lower mass boiler, able to give you plenty of hot water, and able to give you the ability to learn your hot water usage, and it's unlimited cycles. Let's say that you have the kids get up in the morning and you get up in the morning, but they come home at 2 and they start using hot water at 2. At 2 o'clock, the boiler comes out of sleep mode, and it'll stay hot until you stop using hot water after dinner or when you go to showers. And it'll go to sleep all night long. The learning modes were our best invention on that. We also have what's called a double pump mode, where you would leave it in cold start mode. If you wanted the most savings out of the ascent, you would turn the faucet on. You can either pump it twice or let it run for a second. We need a half a gallon a minute to flow across a flow switch, which will bring the boiler out of sleep mode and make it run into the hot water mode until you stop using it. That's the most efficient mode.
Yeah.
The most common modes we're finding people use is the learning modes, because people are impatient. They want to wait that 90 seconds, I believe it is, to come from cold start to getting your hot water. But it's there. And we have guys that are, I had a guy call me and said, I have to use option 2. I have to. And I said, why? He's like, because that's the way it was designed. I want the best savings I can get, because that's how people are. They are sensitive to the
Understandable.
dollar. You know, it's important. But that's the big thing. The 4 options are very important to folks. Option 3 and 4 are the most popular.
Thank you. We got a couple questions backing up. This one's all the way back from Brad Benson.
Hey, Brad.
I'm assuming that's not the Giants lineman. It was a Brad Benson on the Super Bowl
Brad's a
team in the 80s.
Pennsylvania brother.
On the primary secondary, can you review proper setup on the balancing valve? We regulate through the valve on the boiler return, correct?
That is correct. We always want you set the balancing valve. Once you get the temperature up to steady state, which is about 150 degrees, and we want you to maintain that temperature going through the system. Now, we don't want you to have any more than a 40-degree temperature differential going out of the boiler on the primary, secondary, and coming back. So as you know, as you slow water down, it gets warmer. So you want to get a 40-degree delta T between the supply and the return on your injection Ts. Going out of the boiler up into your primary, secondary, and coming back to the boiler, you want to maintain about a 40-degree delta T.
Thank you.
Hopefully that helps you, Brad.
We have another one that's really not a question but a comment, but I still wanted to share it. It's from Long Island OESP. I know who posted this, and it says, "Thanks for helping with so many oil heat cares projects."
It's our pleasure.
I can second that. EK is a huge supporter and contributor, and what Oil Heat Cares doesn't happen without the support from everybody, not just EK. But we're talking to you tonight.
Manufacturers are great. We're the best. Just
it's you go above and beyond all the time with this. A lot of people do.
Amen.
Roger will not say no to somebody that needs help. I've never seen him say no.
Yeah.
I have not either. I can't say it. I'm going to throw that comment out there before we wrap it up.
And we thank you for that, because just so you know, the Pocono chapter just happens to have the Oil Heat Cares Cup this year, so I appreciate that.
I'm well aware. I voted for you.
Thank you.
A comment from Jeremy Martin again. Fast Common Maker can be a lifesaver to those that don't know.
It can.
Yes. Yeah.
But you need to make sure you know how it operates properly. I've gotten calls by guys that don't do what? They don't read the instructions. You're absolutely right, Jeremy. It is a great...
Keep it on the truck.
Yes.
Doesn't help you in the shop.
Don't help you in the shop, no.
No. It's cheap
and it's
easy.
inexpensive. I think they're
That's
like
what I'm saying. It's cheap and easy to have one there.
Yeah.
It makes perfect
Yes.
sense. So I think we're reaching the end of an hour. That's it. I think we'll wrap it up and we'll call it an evening.
Thank you, guys. I had a pleasure.
Yeah.